Hello, this is Professor Sanya. In this video, I'm going to show how to build a linear regression model using RapidMiner and how to evaluate such models. The version of RapidMiner that I'm using is RapidMiner Studio 6.3 Starter Edition. That is the version of RapidMiner that is downloadable for free from RapidMiner website. And I'm using RapidMiner on a PC running Windows 7. Now, if you are unfamiliar with the RapidMiner interface, you may watch my first video where I introduce the interface of RapidMiner and also show how to create and save a process. In this video, I'm going to use a dataset called Toyota Corolla, which contains information on the sale of used car in the Netherlands. To be more specific, these are all Toyota Corolla cars. And to look at the dataset a little bit more detail, we can go to the statistics tab, and we see that this dataset has information on a variety of characteristics of cars, such as the price those cars were sold for, and these prices are in euros. Then it has information on the model of the car, age of the car, manufacturing month, year, kilometer, fuel type, and so on. Now, in the predictive model that we are going to build, price is going to be our dependent variable, and we can choose any or all of the other attributes to serve as our independent variables. Now, just to show you that RapidMiner allows some basic data exploration. For example, fuel type, we can click here and it will show what are the different fuel type cars that are present in this data set. Here is a graph. We can open the chart and it shows the chart. And we can also see the number of cars of each type. So we can click on details and it shows that the vast majority of the 1,000 cars are petrol, 119 of the cars are diesel, and 14 of the 1,000 cars are CNG or gas cars. Okay, so now we can go back to the design perspective and start building our process. First, we have to bring the dataset over to our main process area, and then we'll choose a subset of the attributes that are available in the dataset. That is, to keep it simple, we are not going to use all the available variables as predictors of price. So we can select a subset of attributes, or what is called a dimension reduction, by using the select attributes operator. So we put it here, and in this operator allows us to select a subset of attributes that we can use in this process. So we are going to say subset here in attribute filter type, and then we'll select the subset by clicking on select attributes, and we are going to, let's include age, and we can click this arrow over here, or we can select the attributes. Let's select automatic, and we can press the control key so that we can select multiple attributes. Fuel type, let's select kilometers, and let's select the price. Okay, and now we hit this arrow again. So these are the attributes that we have selected. Now, of these attributes, price is going to be our dependent variable, or the response variable, or the target variable, and the other 4 variables are going to be our independent variables, or the predictors of the price variable. Now, another important concept that I want to point out here is that regression models expects all the predictors to be numeric. Now, kilometer, automatic, and age are already in numeric, but fuel type, as you saw, it's qualitative, that is petrol, diesel, or gas. So we cannot use the qualitative attribute as is in a regression model. So we have to convert the fuel type to numeric, and I'll show how to do that. So at this point, let's go ahead and select these attributes. Now the next thing we want to do is to tell RapidMiner which one out of the variables selected is our target variable or the dependent variable. And we can do that by using the operator set role. So we bring set role over here, and by default the role of each attribute is regular. That is, RapidMiner assumes that all the variables are regular attributes. However, price is not our regular attribute, it's going to be our dependent variable. So we select price over here, and in the target role we change the target role of price from regular to label. So now price becomes our dependent variable for this linear regression model that we are building. Now next, as we said, we have to convert fuel type to numeric, and to do that we have to use the operator nominal to numerical. So this is nominal to numerical, and nominal to numerical operator we can convert fuel type to numerical. So here we'll choose single because we only need to change fuel type. And attributes, see, RapidMiner has already selected fuel type because that is the only attribute that is nominal. In other words, that is the only attribute that we can convert into numeric, because the other attributes are all already numeric. So we'll go ahead and select fuel type. And so what RapidMiner does, it dummy codes these variable nominal variable, and I'll show you what dummy coding means by putting a breakpoint after numerical to nominal. So in RapidMiner, if we want the process to stop at any point, we can put a breakpoint at that point, just like we do in programming. So I can right click on this operator and put a breakpoint after. And so this symbol over here suggests that I have put a breakpoint after this operator. Now I can run this process, and even though the process is not entirely complete, it will stop at this point. So I can run, and you can see that the nominal to numeric operator converted one attribute, which was fuel type, into three attributes. Why three attributes? Because the fuel type attribute had three values: petrol, diesel, and CNG. Now it says fuel type equals diesel, but we can change it to a more accepted text, which is fuel type underscore diesel and fuel type underscore petrol, and I'll show you how to do that. So let me stop the process and go back to design, and numeric to nominal, it says use underscore in name. So if we check this box, then those variables will be all, instead of equal, it will be all underscores. So let's go back again and check it. So now you see that it is fuel type underscore diesel, fuel type underscore petrol, and fuel type underscore CNG. And these are all now numeric variables, and they are ones and zeros, which means that if fuel type diesel is 1, that means this is a diesel vehicle. If fuel type petrol is 1, then it means it's a petrol vehicle. And if the fuel type CNG is 1, somewhere down, then it will be like this one, for example, this is a CNG vehicle. Now note that any two of these attributes is perfectly correlated with the other attribute. That is, if we know any two of these variables, we know the third variable. For example, if CNG is 1, then the other two got to be 0. If the petrol is 1, the other two got to be 0. If diesel is 1, the other two got to be 0. That is, any two of these three variables are perfectly correlated with the third variable. And I prefer eliminating one of these dummy variables, and we can do that by again selecting the select attributes operator, which allows us to select attributes. And I'm going to select a single attribute this time because I want to eliminate only one of those three variables. Now, out of these three variables, I can eliminate any one. However, it's best to eliminate the one with the fewest number of values. And we saw earlier that fuel type CNG has the fewest number of values. There are only 14 cars in the data set which are CNG cars. So that is the one I'm going to eliminate. Now note that select attributes would only select this attribute. However, that's not what I want. I want to select all the other attributes except fuel type CNG. But to keep it simple, or to keep it simpler, I have selected this variable and I'm going to invert selection, which means that it is inverted the selection. That means all the variables except fuel type CNG will be selected in this process, which is what I want. Now I'm also going to remove this breakpoint over here. And now we are all set. So all the pre-processing is done, and now we are all set to add the modeling and evaluating operators. Now, as you know, in predictive modeling, to evaluate a model, we have to partition the data set. That is, create a validation data set and a test data set. So we can do that, but before that I'll go ahead and stop this process. So to do that, we have an operator which is called split data. Now RapidMiner also offers another operator called split validation operator, which makes the process more modular. Maybe in a subsequent video I'll use the split validation operator, but in this video I'm going to use the more simpler split data operator. Now split data, what it allows us to do is to create partitions in data. So we'll create two partitions, and as is the more standard, we'll create one partition for training the model consisting of 70% of the data set, and we'll create another partition by hitting this add entry each time we want to create a partition with 30%, that is with the remaining fraction of the data set. So we have created two partitions, one consisting of 70% of the data, and the second partition consisting of 30% of the rows, and we are done. So we say okay, and there are three sampling types. Now linear sampling, if we choose linear sampling, what RapidMiner will do is it will choose the first 70% for the first partition and the second 30% of the rows from the top for the second partition. Now what shuffle sampling, which is the default, what it does is it randomly picks the first partition. That is, randomly 70% of the data is picked for the first partition and the remaining for the second partition, and that is what we want. So we'll leave it at as shuffle sampling. Next we have to choose the model building operator, which is linear regression. So this is our linear regression operator, and we will put it over here. So this is a linear regression operator. So note that the first partition, that is 70% of the data, is going to the linear regression operator, and the second partition we want to test the model, and to do that we have to use the operator apply model. So here is our apply model operator, and note that apply model operator has two input ports, one which expects the model and the second input port which expects the unlabeled data. The unlabeled data is coming from the second partition, and the model is obviously coming from the output port, the model output port of the linear regression operator. So we created two partitions using split data. The first partition containing 70% of the data, we fed it to the linear regression operator, which, as you can see, the input port is the training input port, which expects training data. And the second partition, the 30% of the data, consisting of 30% of the data, we fed it to the apply model operator. Now, there is only one operator that we have to add before we can run this process, and that is to measure the performance. We have to add a performance operator to measure the performance of our prediction. Now, performance, the operator, RapidMiner offers several performance operators. The one that we are going to use for this purpose is performance regression, and that expects one mandatory input, which is the labeled data, and that is coming out of the apply model. So here is our, I'll make this a little bit over here, and so increase the size of this one. And so now we are all set. Now performance, the root mean squared error, which is the primary metric to measure the prediction, the quality of the prediction, which is selected by default. And we can still say that the first criterion, which is root mean squared error, that will be our main criterion. However, it's also nice to look at the R square for linear regression. And R square in RapidMiner, it's called squared correlation. And so we can check that also, so that we can see both R square as well as the RMSE, which is root mean squared error, in the output. Now, so far we have only put the performance in the output, in the result, the performance coming out of the performance output port in the performance operator. Now, obviously, we also want to look at the regression model, which is a linear regression equation. So we want to put that in the result too. And if we want to look at the predictions versus the actual data in our test data set, that is 30% of the data set, then we can put the examples out of this performance operator also in the result. Now, the number of splines that we add to the result, the number of tabs, those number of tabs will be created in the result perspective. So here we are putting three things on the results. So we'll have three types of results. So now we are all set to run this process and look at our model as well as the performance of the model. So we'll hit the process button over here. So here, see this output, which shows the actual price and the price predicted by our model. Now let's look at our model first, and we'll come back to this one. So the model is in the linear regression tab, and here is our model. And to look at the equation, we can click on the description. So this is our model, that our dependent variable price equals constant, which is 22,278.635 plus 876.269 times automatic, which is a binary variable, minus 0.023 kilometer, minus 0.169.223 h, and so on. Now, let's go back to the regression output. What it means is, number one, the coefficients tell us, the sign on the coefficient tell us whether these attributes have a positive influence on the target variable, which in this case is price, or a negative influence. So for example, it says that if a car has automatic, then its price is, or rather, if a car has automatic, it has a positive influence on the price of a car, as we would expect. On the other hand, if the age of the car is higher, it has a negative influence on the price. That means higher the age of the car, lower is the price. And that's also, it's very intuitive. Now, all these other things tell us how significant this variable is in influencing the price of a car. Now, that is given by the t statistics, and if you are not familiar with t statistics, we can also look at the p-values. The accepted range of p-values is usually, or the accepted threshold of of p-value for a variable to be significant is usually 0.05, and these, as you see, are all less than 0.05, which is why they're all significant predictors, and therefore RapidMiner puts these stars over here. If a certain variable is not significant, RapidMiner would not put a star over there, and the number of stars it puts is also based on the p-value. So here the p-values are all lower than even 0.001. So that's why we have 4 stars. In fact, here this one is not less than 0.001. It is greater than 0.001, which is why we have 3 stars. If it were greater than 0.05, I think it would have there would be only 2 stars. So in other words, what are the things we can glean from this output? Number one, from the sign of the coefficients, we can find out whether this attribute has a positive influence or a negative influence, and from the p-values, we can find out whether these variables are significant or not. Now, let's look at the performance. It tells us that root mean squared error is 1770. Now what does that mean? That means, and it can be plus or minus, it means that on average our model, regression model, predicts the price of used car within a range plus minus 1770 euros. That means, let's say the price of a car is 20,000. The actual price of a car is 20,000 euros. Our model will predict the price of that car within a range of plus minus 1770 euros. Let's look at the R square also. The R square is 0.758. That means about 75%. And this means that our model, with only 4 predictors, that is automatic, age, kilometers, and fuel type, explains 75% of the variance in the price of used car, which is not bad. Now, if we go back to the example, or rather the example which was our third output. So the first output was our equation, regression. The second output was the performance, and our third output was this one, which shows the actual price of a used car and what our models predicted. So for example, in this case, the actual price was 13,500 and our model predicted 17,293. And obviously these are for the test data set. As you can see, our test data set consisted of 30% of the data out of the 1,000 rows in this data set, and that's why we have 300 rows in this data set. Okay, so that concludes my this tutorial on how to build a linear regression model and how to test that model. And before I end, I also want to remind you to always save the processes before you quit the process by hitting save process. Thank you so much for your attention.